And the resulting distribution is going to be distributed now according to this triangular distribution. Okay, any questions here before we try to see how this works in MATLAB? No? Okay, so let's try it in MATLAB. So we have already sampled a million uniform distributions, right? So let's try to make the histogram of this to be triangular between 0 and goes up to 0.5 and go back to 1. How about that? Okay, so in this case, the maximum height of the distribution of the triangular distribution is going to be 2, right? So we are going to be sample another y that's random, the same length as x, and we want to multiply by 2 so that we're going to be stretching the distribution from a uniform 0, 1 into a uniform 0, 2 distribution. Make sense? Okay, and I'm going to say, I'm going to select, okay, I cell is going to be another variable that's of Boolean type, right? Either true or false. That's of the same shape as y. It's going to be y less than the PDF at x. Now the PDF at x is what? Is actually, let me do this first. Let me compute PDF x is going to be equal to, well, if I want a distribution that goes from 0 back up to 2, let's actually come back to here and compute the PDF for our particular example. So our particular example is we want a triangular distribution between 0 and 1. It peaks at 0.5 and the peak value is 2, right? So the PDF at x, it depends, right, where you are. So if x is less than 0.5, my PDF is what? It's 4x, right? If x is greater than 0.5, my PDF is 4 times 1 minus x, right? Or another, just a easier to implement way is just the minimum of 4x and 4 times 1 minus x, right? Okay, so let's do that. So the PDF of x is the minimum of x times 4 and 1 minus x times 4. So that computes a PDF. And I'm going to be computing this Boolean variable. I want to select, I'm going to accept that x or reject that x depending on if y is less than the PDF of x or not. So now if you look at this ICL, it's going to be either true or false, right? 1 is logical type, 1 means true, 0 means false. So that means I'm accepting 1, 2, 3 sample. I'm rejecting sample 4, sample 5, accepting sample 6, rejecting sample 7, etc. So the resulting x is going to be, let's say, x triangular is going to be x I cell. So I'm basically taking a subset of x, right? So x has a million samples. Now, because I rejected the sum of the samples, x triangle only has about 500,000 samples. And now if you make another figure, take a histogram of x triangle. Again, I want to use 100 bins. This is what I get. All right, a very nice triangular distribution that's much less likely to be around 0 and 1 and more likely to be around 0.5. And you can take a look at the algorithm and see how we have achieved this, right? So we computed the PDF of x that's actually a lot larger when x is around 0.5 and a lot less when x is around 0 or 1. So whenever x has a lower PDF, the value is going to be lower. So that means our y is going to be more likely to be less than the PDF when the PDF is high, right? Which means we are more likely to accept that particular x when x lies in a place where the PDF is high. That's how we have achieved, we have made the PDF non-uniform, starting from a uniform distribution. All right, any questions about how we are sampling this triangular distribution?